Well, in 2022, we've hit the milestone, pretty important milestone of 1 terawatt peak of installed PV capacity globally. It's an amazing figure and one we've been working towards for a long time. And in 2022, this year, we're going to hit another record for installation volume right around the world. The records keep falling. And obviously, this means that PV fleets all over the place are growing in size. They're also growing in diversity, and a whole heap of new investors are coming into owning PV assets around the world. Some of them with low levels of experience with PV technologies, and others with a long track record in the energy industry and also with PV technology itself. So it raises the question, with this diversity, with these new owners, with this growing fleet and different systems of different ages, how do we know that they're really performing at their best? How can we monitor these effectively? How can we process these huge amounts of data that are being generated by PV assets all around the world in different climates, conditions, and with increasing severe weather events as a result of climate change? They're big questions, and we're going to be addressing them today in this PV Magazine webinar. Thanks so much for joining us. I'm Jonathan Gifford. I'm the editor-in-chief of PV Magazine Global. And we have three very knowledgeable presenters today. But before we get to our presenters, well, you can see them here up on the screen. I just want to run you through a few of the administrative things here in case you're joining a PV Magazine webinar for the first time. Please send through your questions. I really encourage you to get involved. As I said, we have very experienced presenters, and this is really your chance to pick their brains, to get information from them. So don't hesitate to send through your questions at any time during the presentations, or at the end. We'll have a quick fire Q&A session at the end, but I'll also try to feed your questions in throughout the discussion. So this is your chance to get involved. And if you experience any tech problems, really simple tip is just to refresh your browser. Chrome, I think, is the best browser for this platform, but just refresh that. But we also have our tech team standing by to answer any questions. So again, don't hesitate to reach out and get in touch. We always get asked whether there will be a recording of these presentations and whether we'll be sharing the PowerPoint presentations. And the good news is, yes, we will be. So everyone who has registered for this webinar, and I understand there's a very big number of registrants today, which is great news, everyone will be receiving an email with a link to the recording. And of course, you can share that recording with friends and colleagues who weren't able to attend. Now, the presentations are just around the corner, but before that, I want to hear from you. These webinars are also a chance for us to ask you questions and to get a bit of an idea of your understanding of PV asset management today. Let's launch our first poll. The question today that we're asking is, how much do you think assets will be underperforming? And how much improvement can be expected by employing technologies, monitoring technologies, data analysis? So please send through or register your answer now. Do you think underperformance is not common, so there's no need to improve anything? Some underperformances are not much improved, but can be expected. Some underperformances are, and the majority of them can be improved economically. And underperformance is common, but only limited improvement is realistic. You can only do a really little bit. Or underperformance is common and you can do a lot. A lot of improvement can be achieved, or that you're not sure. So how effective do you think you can monitor and manage your assets? The results are coming in. I see the dark blue line. So people think that we can actually do a lot to manage our assets better. Limited improvement is also the second highest one at this stage. A lot of people also not sure, 20%. Well, the good news is we're here to help. That's exactly what we're doing at this webinar today. So let's close this poll. Thank you very much for sharing your experience, your expectations with us. Now, I mentioned our presenters right at the top. We have three presentations today. Howie Liu is a principal scientist with Envision Digital, and Envision Digital are partnering with us on this webinar today. Nicolas Felix is the operations manager, technical asset management, Total Energies Renewables, and Julian Ascendo Vaquez is the senior solar performance engineer with Envision Digital. Gentlemen, thank you very much for your time today, and I'm looking forward to all of your presentations. Okay, let's get on with it. First of all, we're going to be hearing from Envision Digital with a case study, actually. It's really nice to see how some of these principles can be applied in real life. Howie Liu is a principal scientist with Envision Digital. And without further ado, Howie, I will pass the floor over to you.
Okay, thank you very much, Jonathan. And hi, everyone. It's a great pleasure for me to be here and do some technical sharing with you about the available technologies out there related to digitalization. Yeah, so as Jonathan mentioned, before I start, let me just toss out a case out there for you to think about. So here we have a site, which is a ground-mounted fixed tilt system in a snowy region. And based on the high-level KPIs of performance ratio and the energy production over the past 3 years, this is monthly KPIs. The question is, what can you see from here? Are there any underperformances? Well, if you are an operator who is familiar with the site, probably you know that there are some seasons throughout the year that's snowing. So these months will naturally have lower PR. And then for this side, there's also some kind of data outage or system downtime so that less yield is registered in these months. But apart from that, are there anything else? It looks like this winter is pretty awful. So is this the underperformance? And I'll review the answer in the talk later. Okay, so let me introduce a bit about Envision. So Envision is a global net zero technology partner, and we are a global enterprise. We have headquarters in many regions of the world, and we excel in several business areas. For example, we are one of the top wind turbine manufacturers. We are one of the top battery makers, and the company that I represent is Envision Digital. So it's headquartered in Singapore. And we provide the world's leading AIoT platform called NOS, which is an operating system for energy, as well as smart building and smart city industries. And now the platform is connected to more than 360 gigawatts of renewable asset and over 100 million smart devices worldwide. And solar is actually one of our core business apart from wind. And our solar solution has grown pretty rapidly over the past few years. And by the end of last year, we have contracted more than 70 gigawatts of renewable assets. And our customers include many of the prominent players in the solar space in Europe, US, Japan, Southeast Asia, and of course, China. So we are also very lucky today and very honored to have one of our clients, Total Energy, to share some from their perspective, from the asset manager's perspective, on what they think about the issue. So Nicholas is a lead for technical asset management in Total. So before I share any technologies, I'll just let him to share his experience. And over to you, Nicholas.
Thank you, Howie. Thank you. Hello, everyone. Yeah, so as we said, as I'm here as an owner, so Envision invited me to participate just to share some of our experiences in the field, try to give some concrete examples and try to enrich our discussions here today about this important aspect. So from my side, I just want to give a bit of challenges that we have been facing here, Total Energies. So Total Energies, for those who do not know, it's an oil major from France. And as many of the European oil majors, they are deciding to turn heavily to renewables. So today we have a very large portfolio and growing very fast, which leads us to this slide. As Jonathan was mentioning in the beginning, there's a very steep growth of renewables, especially solar, which bring us many challenges. Our goal is to have 100 gigawatts in 2030, so we are trying to reach that, which of course we're not the only ones, so there's a lot of competition in the market. And Total also grows by partnering or with partnerships, and also buying other companies or assets. So it means that we have a very large variety of data sources and third-party operators in different countries, different geographies, which bring us to a big need that you, for those who are own assets, probably experience. With a growing portfolio, very diverse portfolio, we really want to make sure we have a maximum of automatization, alerts and feedbacks without having to search much for information. And that, of course, gives a lot of value if we know how to use it, if we try to use it well. And we want to leverage the value of data. And of course, it's nice to have softwares, it's nice to have tools and data, but everything plays in the field, right? For those who, like me, had some experience in the field, it's all about a human experience. It's technicians on site doing the maintenance. We want to make sure they have good relationship with them. The data can only help us if we are close to the field, and that's where the game is really played. So what I would like to propose here is go very quick because I don't have much time. So I'll just go quickly through three case studies to illustrate a bit the challenges and how we're trying to tackle them. I don't want to paint here any perfect world, either for the field or from the data, from the tools. It's difficult. We have to work hard to make sure we have good quality data as a challenge, and also to make sure that what we find as losses or improvement possibilities we implement in the field. So this is ongoing process, ongoing things that we're doing. So first one snow cover, and then soiling. And the third one, a bit of the relationship of the contractual KPI with an O&M provider. Just to precise, so the first one is really about how much we lose because of snow, how much we can recover if we clean it, because there's a cost to clean, right? And try to define the best strategy. The same thing for soiling, but also in the soiling case, what we're trying to do is with the data, because we are far away, try to see when the O&M informs us they have cleaned the site, we can check the efficiency of the cleaning and the dates they inform. So it helps us keep a relationship with them and discuss with them about their work on site. And then the third one, show a bit of a downtime of an equipment, and then how we can try to understand that, compare with what the O&M informed, and then see if we can calculate ourselves the contract KPIs. Often, the O&M providers, they provide their own calculation for the O&M, for the contractual KPIs, which is also good as an owner to challenge that and have our own opinion. So the first one here is the problem of the snow. In the you can see the losses in this graph. You see the actual production in light green and expected in dark blue. And then you have in purple the losses. So significant losses, we're talking about 5 to 10%, so more than 7% of losses every year of snow. So there's, of course, an effort from us to try to clear that using robots or manual methods. So we're trying to quantify that and assess that. Of course, there's a problem of the sensors. They are sometimes covered. So we are trying to tackle those issues. So how we're tackling this issue, basically, we want to see if after a cleaning, how much this is effective, so we can compare with no removal, so we can see if this benefit. Then assess the conditions that when cleaning makes sense or not. But of course, if we clean today and we have a snowstorm in the next day, the benefit of the cleaning it's mitigated, right? And then calculate the cost benefit. So just example here, just go through the first step, not going through each step, but it's a graph, a lot of curves of lines. Please stick with me. I'll go slowly so you don't get lost with so many lines. Here we have a comparison of two inverters. So we can try to compare to assess the effectiveness of the cleaning. The dark blue line is the production of one inverter. The dark orange line is the production of another inverter which was not cleaned. They have the same rotation, and behind you have the snow depth. So we have a sensor that measures the snow depth, and then with each inverter we associated the snow losses calculated by the tool by us. It's the light blue and the light orange respectively, and then in the dotted dashed yellow line is the irradiation that we are measuring there. So we can see, as you can see, we had a clear, I don't know if you can see my mouse, but we have a clear cleaning session on after the 22nd and of December. After that, you can see that the snow losses, the light blue curve is going down, while we still have snow coverage in the site, with the background full light blue behind. And the other inverter where we have not cleaned, we can see that the production is going low. The production is not raising as much as the other, and the loss is not reducing as much as the other. So that's basically a first comparison that we do. Of course, we will try to calculate that day by day and through a larger period to try to really assess. So we can see, at least visually here, that there's a cleared the clear zone has got less losses and higher production. Of course, this seems obvious, but when you see in the field the quantity of snow and sometimes becomes ice, the cleaning is not always effective like this. Second example, and I'll move fast here. It's a soiling. So we have some sites close to land where there's agricultural activities, and of course in the harvest or with the tractors working, there's a lot of dust. So this is similar problem with the snow issue. So we want to know when they clean if it's efficient and if it was washed correctly. So again, 3 steps, a bit different, but quantify the effectiveness and then assess the conditions and calculate the cost benefits. So here with ENOS, what we're doing is that in the green lines and the blue line shows the tendency of soiling. So this is the soiling that we are observing, that the tool is calculating, the estimating. The gray rectangles there, it's when our O&M provider informed us that they washed, and then when the blue line goes down, it's when the tool is calculating, is detecting that the wash was done. So it seems fairly current. They seem to be able to clean during several days, and the cleaning seems to be pretty effective in this case. It's not always the case, of course. I'm showing here the case that we can see, but if it's not the case, then will be opportunity for us to go back with the O&M provider and tell them, okay, guys, we're not detecting here. Are you sure the dates you sent us is correct? And then eventually we can send a local asset manager to visit the site and do an audit. And then the last case, and I'll finish with this. We have here some unavailability. So this line here that you see when it goes down is when part of the plant is down, and we have the several categories that we're using here. And some of that the O&M provider sometimes wants to exclude, or sometimes would have a clear visibility, or they identify as a grid outage. So we want to make sure we have a maximum of automatic allocation, so we can have our own view automatically without doing manually. We want to be able to validate each category. If you want to change the category of the outage, if it's a non-owner related, or it's environmental, or if it's with the contractor, and it would affect his availability calculation and thus his penalty. And we want them to meet with them to discuss if ever there's some differences. So here's an example of an outage that they informed. We had this alarm in the inverter, and they said it was a fault in the grid, and we have to meet with them and to discuss with, hey, sometimes the fault in the grid does generate failure in the inverter, but because we have other inverter failures in the site, we might just check, make sure that there was really a grid outage or a grid curtailment on that generated this fault, and then we can calculate the KPIs correctly. And that's about it. That's what I would like to share. So feel free to ask any questions. Thank you.
Thank you very much, Nicolas. Nicolas Felix from Total Energies. We're going to go back to Huawei very soon, but before we do that, I have two questions. Nicolas, if you could turn your camera on and stay with us just for a moment. One question is, you were talking a lot about snow cleaning. How do you clean the modules from snow, or how do you clean snow from the modules?
Yeah, so today we are using manual cleaning. So they go with just some equipment that we can record the snow out. And we are testing a robot. So there's, for snow, we found that there are not many solutions commercially available in the market that are efficient. So today we are trying a robot. We're still under commissioning, so I cannot give much data for now. Hopefully next year we can have more information, but today it's manual.
And I suppose it's a bit of a balancing act, because we know, we've always heard that when the modules heat up, when they get some sun on them, that the snow will kind of slide off. And then, potentially if there's rain, then that will also clear them. So it's a balancing act. You have to decide, should we roll the trucks to clean this, or will the sun come out and do it for us? So how do you make that decision?
Yeah, exactly. It's a good point. So the decision to send the team, so the team is not mobilized every day, of course. So the decision to send the team, it's forecasting the snowfall for the next days first, because we don't want the snow to fall right after the clean, and also see the temperature. So we know that if the snow stays a bit and the temperature goes very low, the snow becomes icy, and then it's really hard to remove. So we want to make sure we react to that quickly. But it's a big challenge indeed.
Yeah, there's quite a few variables in play. You also spoke about soiling, and we have one question about soiling. What tool do you use for measuring the soiling level?
So this is what I showed. Today we are using ENOS. So we're using Envision ENOS that can detect. So basically they have the algorithm that how we can maybe explain better how it works. We do have reference cells on site that we can try to use them. But the difficulty is that the sensors on site, you often require the maintenance of the O&M provider, and we're still working with them to get good maintenance so we can trust the measurement on site. So today we're using the data only to have this measurement, and then we discuss with the O&M provider if there's a distortion or difference.
Okay, very interesting. Thank you. Nicolas Felix is the Operations Manager, Technical Asset Management with Total Energies Renewables. Thank you very much for your presentation, and stick around for the Q&A at the end if you can. Now, continuing with our presentations, Howie Liu, the Principal Scientist with Envision Digital. Can you please take over?
Hi. Yeah, sure. Great. So let me thank you very much, Nicholas, and let me continue to talk about some technologies. So the first part that I'm going to cover is smart monitoring and analytics, and later on, my colleague Julian will talk about what's beyond that. So, sorry, it's a bit stuck here. Hold on. Okay. All right. So yeah, the first thing is monitoring. So I hope that the industry nowadays had already come to the consensus that monitoring is an integral part of any PV system. And then actually it is, because it forms the very basics of digitalization. And it serves many of the core business needs on both the site level and also the headquarter level, such as operating the farm and also keeping track of productions. And nowadays you find many monitoring softwares out there which can offer nice product features to help you do that. And of course, Envision is one of them. But today I'm not going to elaborate too much on that, because I think the audience might be very familiar with this already. But then what I do want to highlight is one thing, which is the algorithms that can make the monitoring a bit smarter. So one example would be alarms. So alarm management is one of the crucial functions of monitoring. But time and again, we hear customers feedback that they are facing unique challenges for managing alarms of PV farms because there can be so many of them due to large number of components and large variety of alarms. But then many of them are actually related or repetitive, such as the same error message across many different inverters, or topologically related alarms due to a parent device going down, triggering tons of alarms in its child devices. And then because there are many data collection points, so data quality and communication issues can sometimes creep in as well. So the solution to this needs to be some kind of smart alarm aggregation, filtering, and even delayed notification for those less critical alarms to allow time for the system to auto-confirm what's going on before sending it out. And the result is a greatly reduced number of alarms to a manageable level by human operators to respond to. Well, this is conceptually simple, but to realize this, the system needs to know how the system works and then be very familiar with all types of alarms that can come up. And then, of course, it needs also to have some topological information about the devices and also digital twins, and then need to make use of all the information that are available on site to be aware of what's going on. And then next level beyond monitoring is, of course, advanced analytics using the monitored performance data. So in our view, there are a few key elements to that. Well, the first thing is, of course, you need to know what the system is undergoing at every point in time and be able to detect it into a standard set of conditions and to allocate status and responsibilities. And then next, it is desirable to disentangle the major loss components to achieve asset transparency. And then based on this information, we should have cost and benefit evaluation to find out what's the most valuable item to act on. And then last but not least, all this should be done in an automated fashion because obviously it's not a good solution to need to hire a lot of performance engineers or analysts as you grow your portfolio. So all these should be done automatically by some kind of digital platform or system. And then let me just elaborate on the first point a little bit. As we know, it's quite obviously important that as you run a power plant, you need to know what status it is undergoing. And but this is not a directly measurable quantity or some signal to read from, especially for solar farms, because you have so many components and so many possible states, and then these states can even change over the course of the day. But then luckily you have a lot of information being collected as it runs. One of them is the equipment's original status signal. But the challenge here is the different models of the equipment can give very different representation of their status. So what we do is we need to standardize them into some kind of standard equipment state or fault state, and then at the same time make use of the contextual informations like the various monitoring points or control signals or even derived data like the sun position from the timestamps to help make sense of what's going on and then transform these raw information into some kind of standard availability status, like the one according to IEC status. And this is done like via edge computing or streaming calculation in an automated fashion, but then also sometimes need to take into account the operator's inputs as well. And apart from this, NOS Analytics also calculates the operational status, or what you call loss status. This is just a more detailed categorization of what the device is undergoing. Like, is it undergoing curtailment, shading, or snow, or a tracker is in a deviated state, and so on. So these things are automatically detected by some algorithms, and it will be very helpful in breaking down losses downstream. So what are the losses that can come from the field? Well, it can come from operating environment, such as snow, soiling, and it can come from constrained operations, like clipping curtailment, or when the grid operator puts some command on the power factors or of course, it can come from the equipment themselves very often. And it always struck me that all those hard-earned efficiency gains in the lab or in the manufacturing line for these cells and modules, well, they can sometimes very easily be lost due to these field conditions. So selecting or uh, choosing the right equipment or component is not the end of the story. And you actually need to know what loss is going on in the field. So that's very desirable. But then breaking down these losses are very tricky and challenging. But we're not here today to talk about the technical challenges or our solutions. Actually, we don't do loss breakdown just because we think we know so much about the system and we feel so good about being able to tease them apart. No, it's because this actually has some value to offer to O&M as well as the asset management practice in general. So here we listed a few use cases that can benefit from loss breakdown. Well, firstly, I hope it's very obvious that once you know where the losses are coming from, it gives you the idea of what are the improvement opportunities. So in the end, it will help you maximize your yield. And that's a very concrete benefit, which we will see an example just in a bit. But equally important is the transparency and the operational efficiency that this gives. For example, for the O&M providers, they can use this information to have more efficient troubleshooting or more targeted field actions so that they can lower their cost. And then at the same time, they will have easier time to abide their contractual obligations and to satisfy performance guarantees, but at the same time, not being blamed for the underperformance that is not they're not responsible for. And then for asset managers, it's even more relevant because they need to constantly have oversight on not just the plant performance, but also the vendor performance, like verifying the washes or evaluating whether snow removal technique is efficient, like what Nicholas just shared. And then asset managers will often also do benchmarking of the real performance against the performance model, the loss assumptions that they made in the financial calculations and so on. And on the operational side, they constantly deal with contractual assessment and obligations. And then they also do a lot of reporting to various stakeholders. And for that, having asset transparency is actually tremendously helpful for them to do that more efficiently. And we'll see that in example as well. So right now, let me just look at the first example.
Actually, before we get into the examples, Howie, I'm sorry to interrupt your flow, but I thought that now we're talking about some of these challenges that we could look, actually ask our next poll in terms of some of the challenges in O&M. Okay, fantastic. Well, you stick around. Let's launch the second poll now. So from everyone attending today, what do you think is the biggest challenges you face in managing PV farms, including performing O&M? Is it manpower resource constraint, access to sites and truck rolls? Is it vendor solution integration? Is it data management, which we're hearing about right now, collection, quality, curation, etc.? Is it asset oversight, communication and accountability, reporting to stakeholders, contractual compliance, which we've had a few insights into, responsibility, warranty, insurance, or is it consistency and reliability of work? So I think this really taps into exactly what you were addressing just then, Howie. So interesting to see what are the biggest challenges in managing PV farms, including the O&M component. And it looks like at the top at the moment, by a slender margin, is that data management. So making sense, I think, of the information, knowing when to act, knowing how to act, and to get that transparency, but also asset oversight, communication and accountability, reporting to stakeholders. Okay, really, really interesting. Okay, well, I think that can inform some of our discussions a little bit later on. So I think at this stage, we'll close the poll and back to your presentation, Howie. Thanks for that.
Yeah, thank you. Yeah, it's indeed. So to get this entire system digital platform working and ensuring reliability and quality is actually a lot of engineering challenges behind that. Yeah, and of course, there's lot of things to be discussed there. And yeah, let me just get back to the case that I mentioned at the very beginning. Yeah, so it looked like that there's underperformance in the third winter here, but actually what happened here is actually in the second winter there is some kind of inverter issue where the subcomponent is broken, and then it leads to a derated curtailment clipping. So what happened, like what is shown in the 3 days here, is you might have snow on the first day, snow melted on the second day, and then the third day is sunny, but then the system is operating at a lower clipping limit. So that is what we call partial capacity loss. And it's happening amidst the snow season. And then for the third winter, it's just simply heavy snow. It's a bad year. Other than that, it's nothing wrong. So so how much does this issue cost? So we have calculated the theoretical generation without partial capacity loss. So this is the green curve here. And it actually leads to quite substantial amount of loss every month. And it gets heavier towards the summer, of course, because there's a lot more sunshine and a lot more clipping loss. And then, so as you can see, if you can identify the problem earlier, before the snow season ends, you can actually recover quite a bit of generation. But then, of course, this snow event also masked the issue to a certain extent and didn't get fixed. And what's more here, the site has certain communication issues or system downtime that also um, mask the issue. So that's why having loss breakdown is pretty important. So in our product, we can actually break these down and then have better visibility. And I hope you do see that from just the KPIs themselves or even historical comparisons. It's very hard to notice this kind of underperformances. And then next example relates to the KPI customization. And actually the asset managers, they like to calculate a lot of KPIs, availability, performance ratio, performance index. And then each kind of KPI has many variants as well, including the ones that the practical ones, like which are the measurement source that you want to put into your calculation for the solar irradiance or the energy generation. And then is there any corrections that needs to be applied? And then the beauty of having availability state and operational state being calculated and detected here is that it gives you a lot of flexibility in choosing what to include and exclude in your KPI calculations. And that will give you the ability to satisfy the various accounting needs from various clients or contracts. So I think this is a very handy feature. Okay, well, due to time constraint, these are the only two examples I can share today. But actually, we have more, a lot more concrete value creation cases, which we plan to show in our upcoming webinars. So do keep an eye out for them in our website or LinkedIn account. We will make announcement for that. And yeah, thanks a lot. So next, I'll pass it to my colleague. Yeah.
Fantastic. Thank you, Howie Liu, who is the principal scientist at Envision Digital. Thank you for that. And thank you for also letting me interrupt with that poll question. I think it was helpful to get that information from our attendees. Excellent. Yep. Well, moving on with our final presentation for today before we get into the quickfire Q&A round is Julian Asensio Vaquez, the Senior Solar Performance Engineer with Envision Digital. Julian, thank you very much for joining us today, and I'll pass the floor over to you.
Thank you, Jonathan. Thank you very much. So my name is Julian Asensio, and thank you to my colleagues to present the very interesting cases before, and Howie for setting up this webinar. And actually, we will show to you what is beyond the Envision products. What do we think as a digital solution for advanced diagnostic and OM, as well as asset management? What can we do with this? What we have the platform. What can we do beyond it? So the first case study is the IV curve diagnosis. So we go there. What is IV curves? What they represent? We can measure them in the field or not, and we can see by comparing the current and voltage, different shapes, and then different root causes of different underperforming events. Here's some examples, but I will move forward to the next slide to show you a little bit more. So what we expect from a NOS cloud platform and the digital platform, what can we do with IV curves? You know, today we can measure in the field with IV tracers, or also smart inverters. They have this triggering for IV scanning. That is the information coming from the field. But what can we do with that? How can we combine all the technology we do have through the monitoring platform, advanced analytics? So in here, having this digital platform, this smart brain, let's say, coordinating, managing the data, is how we can bring more value. And that is a value creation we want to bring to asset management and operational maintenance. So we want to optimize the field inspections. We do want to track the health of the PV modules through this. So we need to look to the dates where this was measured. We need to look to monitor the health of the PV modules over time through the IV curves. So this is one of the possibilities today. We can upload our information via IV tracers or automatic IV scanning to the platforms, and combine data and get to the advanced analytics. This might help everyone, not only asset management, but also operators. If we can move to the next slide, please. The second case study is a drone imaging. This is, you can hear more and more about this. What is drone imaging and how it's helping in PV. So we might have two different solutions: temperature, infrared imaging, for example, or electroluminescence in one side. With temperature, we will see some issues as connection problems, diode problems, module problems, and etc. With EL, we might see PID, cells cracks, and more detailed. And what is the benefit of this? So with an advanced analytics product, we will have a high resolution in a temporal scale, a high resolution tool over time. But with the drone imaging, we will add on this spatial resolution, where we can not only look to inverters and strings, but also go to modules and cells. But we have some difficulties, right? So if we move to the next slide, please. How to combine, how to make something smart. And that is why NOS and Envision Digital is offering those products as a digital platform. How to optimize this. So if we compare with a healthcare system, the monitoring platform, the advanced analytics, is like your basic upkeep. So every day you feel you can feel your health, understand your body and how it's reacting, right? So the same you are doing with a monitoring platform. You check every day how the performance of a system is working. But then you start feeling a little bad. You see something in the monitoring platform, then it's not really right. You don't want to trigger straight on the specialist, right? So you will go to the primary care. You will maybe ask your technicians on site to go to check something. And then you will suggest, you will get some corrective action. What should we do now? Should we really go for the specialist or not? So if in your body you are feeling this is not right, your primary care, your principal doctor said, hey, this is not right, we need a specialist. So we'll move forward and activate the drone-assisted thermography services, for example, which is a more expensive service. We cannot do every day. We might do once a year, every 6 months in the best cases. So we need to really optimize when to trigger such operations. As Nicolas showed before for Total Energies, this is something really critical because they are operating from one country, sending the technicians in another country. So the communication, how effective are the operations for drone imaging in this case, but also for soiling and snow, it has to be very efficient. So let's say we needed to go for the thermography service. Then we can also trigger EL, but all this will come back to the integrated analysis. So we need to combine this monitoring data, the advanced analytics from the SCADA with the drone imaging, and then decide and then suggest some corrections, fix some problems, and everything has to be in direct contact with the technicians on field. As Nicolas also mentioned, those people are the ones playing the game there in the field. So they need to be very clear. We need this transparency from the operational data point of view to the field point of view. So in this case, once we combine all the data, we can come back to a normal operating condition and then start again. So if we continue with the next slide, we will have other solutions. So beyond this digital platform, what else can we do? And we need to integrate, as we saw in the second pool, the data management, it was like the highest voted concept there. Data management is a problem. So we need to integrate. Today, we are having more technologies in the PV plants. We are having more data. We are integrating soiling sensors. We have the monitoring platforms and the advanced analytics algorithms behind, but how to integrate that? And in that way, this holistic digital platform will allow you to do so. So we will connect the soiling sensors to the algorithms, but at the same time, the algorithms, as Nicolas also showed, and in this plot is from one of our products, they need to connect, they need to communicate, they need to be efficient and optimize field operations. So let's make this algorithm talk also with cleaning robots, or in another field, the same case with drones. Let's talk with the drones and say when to fly and when to optimize those operations. So this is a concept we want to bring today to all the audience. Is we need the digital platform, we need to store the data, to manage the data, to have advanced algorithms, but everything needs to talk. And this figure is representing, for the soiling case, how everything can be in a closed loop. If we move to the next slide, please. So the last case scenario, and what can we do beyond a digital platform? And this is a ultimate case when we need to communicate with in all cases, and sometimes in real time. So the augmented reality for operational maintenance. This is something you will start hearing more and more, because it is coming with virtual reality and with international operations and overseas. And so what can we do with that? We need the cloud. We need a digital platform controlling, managing the data, as well as triggering very efficient field operations. So in this case, if we want to do such augmented reality, imagine the technicians going to the field, they can at the same time be communicating with the central database or those algorithms and looking in real time, seeing there what is happening with the inverters, or maybe access to the manuals of the inverters, and all in the real time, as well as locating yourself in a map, in a 2D map, in a 3D map, in how this, where are you positioned in the system, which inverters to go, and then again to have more efficient field operations. If you can go to the next slide. So today, I show you those 4 cases, and I also invite you to read the white paper my colleagues wrote. This one you can see with the click. So about the holistic asset management, and you will find more information about what I mentioned today, what Hauke we mentioned today as well. So please go and visit there. So to start finalizing this webinar, we have this holistic digital solution, but it's not only about technical challenges and business challenges for asset managers and operational maintenance. We want to bring you desirable outcomes. So we'll have a long list of challenges, but how to make sure that we are bringing the desirable outcome. And this is where you can see in the market different platforms, Amazon, Microsoft Azure, or others. But what if you combine those platform capabilities with built-in expertise? In this case, we are showing you for solar. The same scenario can be for wind and storage and other renewables. So combining those two, we'll have something very powerful, right? So how we show, for example, the loss breakdown, but also we combine with the best practices, we optimize the information, we have common building blocks. So we can very fast build new products, new applications, as I showed you in the previous examples. So in here, the several desirable outcomes for solar, they will be a baseline insurance, the cost reduction, and we always try to maximize the yield, to offer total transparency for our international clients, having global operations, and make sure that we have consistency in our algorithms, and you can have this consistency over your entire portfolio. At the same time, allowing this technology diffusion and talking with different partners and stakeholders. Next slide, please. So just a summary of what we presented today. It's a lot of information. The slide will be available. You can go to the white paper as well, or contacting us. But so IoT, digitalization, and automatization of these things are essential to address the future challenges of running an entire and a global renewables fleet, not only in solar, in wind, and in the new technologies upcoming. So we have a baseline, and this is more than management and technology. Actually, as the title of this webinar, we are achieving excellence because we combine those platform capabilities as well with the expertise. And the expertise is translated in advanced analytics, loss breakdown, and other different algorithms we have behind to help operators and as well as asset managers with different aspects of their daily work. And this technology fusion, so very important, how to integrate the data. We saw in the pool number 2, data management is one of the main issues. So we need to understand the data, to process it, to make it consistent over different applications and providers. And one of our last thought, so what is a good digital platform? So it's not only about traditional processes, but we need to combine this technical expertise. We need to combine with best practices, and as well as this transparency with our users, as well as all the operators and all the stakeholders at the end of the day. So with that, I want to finalize the presentation. Here we have the contacts. You can contact our sales in different regions of the world, as well as Hauhui for technical questions. And you can visit our website for more resources. So thank you very much, all the audience. And Jonathan.
Thank you, Julian. Julian Asensio is a senior performance engineer with Envision Digital. Thank you very much for that. Now you stick around because we have our Q&A round with all of our presenters today in just a moment, but let's get our third and final poll question to you, our attendees today. Which technologies do you think will be highly relevant to you in the future? Is it AI-enhanced data analytics? Is it automatic IV curve scanning and analysis? Is it data-driven warranty claim support? Is it soiling analytics prediction and robotic cleaning? Or is it smart tracking? Which technology do you think will be highly relevant to you in the future? Votes coming in, and we do have a lot of questions coming in, so we'll have to get into our Q&A round very quickly. Soiling analytics is seen as being very important. Also, AI-enhanced data analytics, which is out in front at this stage, 33%, but a relatively good level of interest across all of the 5 different technologies. But it's really the data analytics that is out in front, and also soiling analytics, prediction, and robotic cleaning, which really shows you that, we'll close the poll now, shows you that automated processes in O&M are seen to be a really important development and an encouraging one. Okay, let's move on to our Q&A round. Julian has stuck around. We also have Nicolas Felix from Total Energy and Howie Liu from Envision Digital. Gentlemen, welcome back to all of you. Let's get straight into it. Julian, I think this question is for you. Do you have a business case of TCO, total cost of ownership, of this kind of solution, soil sensors plus robots plus cloud solution, and additional CapEx, OpEx versus improved O&M efficiency and production gains? What's the ROI? That's the bottom line. Get straight to it.
Wow. In my head, maybe Hafu, you can help me out on this one. Do we have a something
No,
there?
actually,
Some number.
So the second part is actually more forward-looking, and we're discussing some future ideas that the industry we can see the industry going. And so currently we don't have an actual case which implemented the closed loop soiling and cleaning. Well, what we have right now is just the upper part where we see the soiling monitoring and algorithms. So that part is pretty straightforward, and I think Nicholas had already showed that it can help with cleaning and help with field operations. But then the soiling sensor is another thing that we are also working. So we have the capability right now to include soiling sensors in our Japanese client as well. And then yeah, so they will help with the refine the algorithms that we do with the data analytics, and also to help with planning the washing. And that is actually a pretty good ROI. I don't have the number on top of my head, but obviously washing is not cheap, especially in labor expensive regions or in dry regions. So these are areas where you do need to optimize it.
Okay, and I'm sure you can work on a case-by-case basis, depending on all those different variables.
Yep.
Julian, I do think the second one is for you. Can you explain the difference between thermography and electroluminescence in terms of possible findings?
Oh, okay. Yeah, so I will not go too much into details because of that, but so thermography is well known today. You can find a lot of providers and in all different regions. And then we will try to, so we will measure the temperature of the models. We will analyze what is happening through the temperature. So you have to do it during the day to see how much is they are generating in terms of heat as well. So what you can find out of that is the mismatches, is to see, for example, the diode problems, if you have interconnection issues. But EL is something you will do during the night most of the time. So in here is where you inject the panels with current, and then they will start providing this luminescence out. So the camera is completely different. The technology is way more expensive as well. In here, we can go to very high levels. So in spatial resolutions, we go to cells. So the most used is cracks. So you can follow cracks over the system, but then also get other parameters through this different technology. But it's some very sophisticated technology today. Yeah.
And the cracks with the EL show up as hotspots, don't they?
Yeah, they can be related. So this is where we need this smart digital platform to combine such information.
Okay, and another question about drone IR and EL over time. Do you analyze drone IR and EL over time automatically, or is it a human that selects abnormal cases and additional measures that need to be taken?
So as we mentioned, those are technologies beyond what is today in the market. So we are actually communicating with the vendors. They do have their automatic algorithms to detect. There is some supervision. They are just verifying the results at the end, but it's algorithms due to the large number of images. So for a system, imagine how many images you have to take. And since EL you analyze at the cell level, it's almost impossible, maybe impossible for a human to do manually. So all is automatic today.
Mm-hmm. Sure, and an evolving field as we get more sophisticated drones, imaging, and also just build up the data over time, I imagine. Nicolas from Total Energies, I want to bring you back into the conversation. Could you please share the most important KPIs for O&M contracts when you're managing your projects?
The most important KPIs, A classical, of course, the classical one is a time-based availability. That is the classical one. We do try to discuss with the O&M providers, depending on the location or the site, to try to include something more related to the PR, performance ratio. So those are the two main ones. Production-based availability would be something very good, but you do have to agree with the O&M provider before, so you have an automatic calculation. If not, it's too complex to calculate it. So those are the three things.
Okay, interesting. Thank you. Howie, over to you. Which programming language is used for the analysis solution? Can you reveal that?
Well, actually, that is not strictly programming language dependent. So yeah, we on the back end we develop we do research and development in Python, but then I don't think this is programming language matters. Yeah, for NOS, it's a full-fledged digital platform and it's a conglomerate of many tools and functionalities. So yeah, it's not just a single programming language. It's not a kind of workshop style where you develop some scripts and then just run that script. Yeah, it's a product that we implement and then refine it on the platform side. Yeah.
Okay. And can you say what are the prerequisites must a solar asset have to fully use your solution? For example, do they need to pre-install sensors in each string?
Well, actually, for our solution, we always try to keep to whatever is available at the solar farm. But ideally, of course, the data, the richness of the data is important. So that's I saw in the poll question as well that so it is a pain point to get this data management right. So and we do see it in a lot of our clients as well, like data quality, whether they collect enough data and so on. So there's a lot of engineering challenge that goes into building up this system, and that's something related to the platform capability that we talk about. So having a monitoring platform that's scalable and at the same time ensures good quality, easy to onboard the assets and so on. So that's something that we worked a lot on our NOS platform, and we kind of build digital twins using the best practice so that so we have like gigawatts, tens of gigawatts of assets onboarded in just a very short time in China, because we have such a good tool to onboard these assets. And then, of course, to use advanced analytics, it is good to have some background information about the devices, about the like the inverter or string capacities, and these are basic information that we would need to have, and the weather station inputs as well. But as we move along, the algorithms will get more and more intelligent so that it will auto-detect a lot of the parameters so that you don't necessarily have to input that, but it can detect from the data. So that's also one thing that we are working towards.
Okay, and I think we have time for one last question. Are there any Envision specific PV data analysis algorithms open source, or are any of them open source on GitHub, for example, or is it all kept in-house?
Well, I think at the moment we don't have open sourced algorithms, so these are all our proprietary, and we do spend a lot of effort developing that. Yeah, I'm not sure whether in due course we will make some of them open source and as a tool for people to apply. But I think some of the there are some good tools available, like PVLib and these toolbox that can help you with some essential solar related calculations. But then to do a full-fledged like analytics for big fleets, big assets, I think there's still a lot of challenge into going into developing customized scripts, because and also we do spend a lot of effort making sure that the results works for all type for a diversity of assets. So be it in a solar in a dry area, desert, or some cloudy region. So these are all different. So it's a lot of challenge indeed. Yeah, and the script would be, I think, would be too complicated for ordinary operators to operate. So that's why we stress the point of having the expertise built into the system, and then we'll make sure that the automation is done best for our clients, instead of having them to manually try to piece things together and make things work. Because in our experience, sometimes that can be very challenging. And we know that some of the more savvy customers, they like to develop their own analytics. Well, they can do so on top of our analytic results or on top of our analysis or partially analyzed results. And we do expose them via APIs so that they can calculate stuff and then do their own investigations on top of that. So that's one way to build on top of what our tools offer. And another thing is for the NOS, they actually have the capability to so if you subscribe to the full cloud solution, you'll be able to develop your own analysis pipelines and scripts on the NOS platform. So that's another model that's possible within our product.
Okay, interesting. So that you can use it as a platform and then tailor it to well, do some work and develop your own insights. Interesting. Okay, I think we have come to time. I saw that someone needs, Nicola, your the conference room that you're in. So I think we might have to end it here. Thank you very much, gentlemen. We couldn't get to all of the questions, but thank you everyone for sending through your questions. At this stage, I will bid our three presenters farewell. Thank you again for your time today. Howie Liu, the principal scientist, Envision Digital; Nicolas Felix, the operations manager, technical asset management with Total Energy Renewable; and Julian Asensio, senior solar performance engineer with Envision Digital. Thank you very much for your time today, gentlemen.
Thank you.
Thank you very much.
Thank you all.
Bye-bye.
And thank you everyone for attending this PV Magazine webinar. Please do make sure that you stay in touch with PV Magazine via our websites, 10 websites now in many languages all over the world, and of course our print magazine. And as it happens, the April edition of PV Magazine each year is our quality edition. And this one hit the shelves last week. For a little thank you for attending our webinar, you get a 10% off, 10% discount on subscription. I really do recommend you pick up the edition. It has a really 360 view on quality, on asset management, right all the way from production right through to built solar power plants. Lots of expert comment, analysis, articles, and news in there. I encourage you to take up a subscription, and also your subscriptions help us continue to do our work here and present webinars like this one. I mentioned our websites. You can see some of our most read articles from the last week or two up on the presentation now. And of course, stay in touch with our websites to check out the upcoming webinars. And you can use the QR code that we provide. Oh, here are the most read articles. And you can use the QR code that was there to check out what upcoming webinars we do have. We have a big array of webinars coming up in the next few weeks and months, so stay in touch, join our webinars, be a part of it. But until then, my name's Jonathan Gifford. I'm the editor-in-chief of PV Magazine Global. Make sure you fill in the survey at the end of this webinar. It really does help us to make our webinars better for you. So if you could take a minute or two to fill out that survey, we'd be very grateful. And thanks for your attention today. This has been a PV Magazine webinar, and thanks for your company.